Hi there, welcome. We are going to be going over a few examples for how to solve one-step equations where the variable, in this case we're going to use x, is being multiplied to a number or a coefficient. So in this case, we have -3 is being multiplied to a variable, and that equals 15. So we're essentially looking for some number times -3 to equal 15. So we could sit here and guess and check values of x, or what we could do is solve this using what is called inverse operations. So to figure out what proper inverse operation you need to use, the first thing you have to do is look and see what operation we're currently doing to the variable. This -3 is being multiplied to the x, which means we have to do the inverse or the opposite of multiply. So what we're going to do is not multiply, but divide. So this line that I just drew right here is a division line. Essentially, and just to keep our work organized, sometimes I draw a line down my equal sign just so I know that everything that I do to the left, I'm eventually going to do to the right, but I'll go over that in a minute. Essentially, our goal is to get x all by itself. So what we want to do, and let me draw that x a little nicer for you. All we want to do is eventually get x all by itself. Now, the real question is, when x is by itself, what is the coefficient of the number out front? The coefficient is not 0, but in fact, and your teacher might have taught you this already, there's always an imaginary number 1. So we'll put an imaginary number 1 right out front of that. So that really means that our goal is to make this number right here, this -3, turn into a 1. In order to do that, it's very simple. We use what I talked about a minute ago. It's called using inverse operations. Instead of multiplying, like we're doing here, we will divide, like I drew here. But what number do we divide by? We're looking for a number that we can divide -3 by in order to make it turn into the number 1. The good news is, something that you've probably learned a while ago, is that any number divided by itself is equal to 1. So when you take a number, whether it's negative or positive, and divide it by itself, this right here turns into a giant number 1, because any number divided by itself is 1. So now all we really have on the left side is this 1x. That's good news. That's what we want. But when we're working with equations, we have to keep them balanced. You can almost think about this like a seesaw, right? Where this is the middle of the seesaw. And what we just did is we unbalanced it because we did something to one side that we did not do to the other. So here's the rule. If we do something to one side, like divide by -3, we have to do the exact same thing to the other side. Divide this by -3 as well. So far, so good. Now, this does not cross out to be a giant number 1. Instead, we actually have to solve what is 15 divided by -3. Well, 15 divided by 3 is 5. And when you have a positive number, because this 15 is positive since there's no sign in front of it, divided by a negative number, anytime you have any positive divided by any negative, your answer is negative. So we have our answer to number 1. X is equal to -5. And to double check that, you could plug that in if you want to. Is -3 times -5 15? And I believe that a negative times a negative is a positive, so that one checks out. Okay, moving on to example number 2. So this problem is very similar. We have a number being multiplied to x. This time it's a decimal, but that's okay. We can work with that. And we still need to do what's called isolate the variable. Get it alone all the way down here. And remember, getting it alone really means that we want there to be an imaginary 1 right out front of it, just like that. So we're going to use the same method we used before, called inverse operations. This 0.2 is being multiplied to x, so we are going to divide by 0.2. If I can get a decimal in there you go. Because any number divided by itself is a giant number 1, just like that. So we just cross that out, so to speak, and now we have 1x all down here by itself. Just like the last problem, we have to make sure we balance this. If we divide the right by 0.2, we also have to divide the left by 0.2. There we go. Now this one's a little tricky, right? Because we have a whole number divided by a decimal. So if you are allowed to use a calculator in your class, please feel free to do so. There are a few other methods you can use if you would like. For instance, we could bring that decimal 1 spot to the right. Instead of making it 0.2, just make it 2. But then if we do that, we have to add a 0 to the top here. Essentially what we did was, we took this decimal, slid it over one spot to the right. We can take this decimal that's right here next to the 4. It's imaginary, but after a whole number is always a decimal to the right of it. And we could slide this one spot to the right as well. But now there's a big empty space there. So instead of leaving it empty, we filled it with a 0. So just a method to get that answer. And then, of course, we could do 40 divided by 2, which I believe is all right. So far, all we have done to get this final answer where the variable is isolated, meaning it's all by itself just with a coefficient of 1, is really just divide both sides of the equation by the coefficient of x. Let's keep going. Let's see another one that we might see in this activity. All right, so this time we once again have a number in front of the variable. That means that it's being multiplied to that variable x. Even though it's a fraction, if there's no symbol inside here, right? There's no plus or minus sign, there's no division sign. That means that we are multiplying 1/2 times x. So in order to get x all by itself, isolated down here at the bottom, waiting for us to put the answer, we're still going to want to do the opposite. So if it's 1/2 times x, we're still going to do divide by 1/2, because once again, no matter what the number is, any number divided by itself becomes a giant number 1. Now we have, oops, sorry about that. Now we have 1x is all alone. This one gets a little tricky over here on the right side because don't forget, whatever we do to the left, we also have to do to the right, or whatever we do to one side, we have to do to the other. We have to divide this by 1/2 as well. If you have gotten to this part in your class, you probably know what to do. Anytime you are dividing a whole number by a fraction, you may want to go ahead, and we're going to just do a little side work up here out of the way. We'll put -3 over the number 1, turn it into an improper fraction. Instead of dividing by 1/2, I'm going to multiply it by the reciprocal. So again, this one's a little tricky just because we have to involve a few more steps and a few more things that we might have learned in the past. But that's what math is all about, right? Building on what we already know. All right, so this time we have -3 over 1. Instead of division that we had here, we're now going to multiply it by not 1/2, but the reciprocal. That's called, instead of dividing by a fraction, you can multiply by the reciprocal. Going straight across, there's nothing to simplify. This would just be -3 times 2 is -6. And then really, 1 times 1 is 1. I don't really need to write it over 1. I can just up here. But for my final answer, I'm going to leave -6 all by itself. So your answer will look like this. And your teacher might even say, please don't write the 1 in front of the x. So you can always just have x is equal to -6 for your final answer. And with that, let's just talk about one final example that you might see in this activity. All right, so this one looks pretty straightforward. I'll draw the line down the middle of my equal sign just to make sure that I keep things separate. I once again have a number 24 being multiplied to my variable. To get rid of it, I will do the opposite of multiplication. That is division. Divide this by 24, or should I say -24, because any number divided by itself gives me that number 1 in front of my x, and that's exactly what happened here. We have the -24 divided by -24 gives me a giant number 1 down here as my coefficient right here, I should say. But once again, if this was a teeter-totter where that's the middle, well, now it is awfully slanted on that teeter-totter because, or that seesaw, because whatever we do to one side, we have to balance it and we have to do it to the other side. So we would have -6 over -24. Now, 6 over 24 or -6 over -24, that is not going to be a whole number because it's a fraction where the top number is larger than the bottom number. So rather than dividing these two numbers, I think what we can do is we can simplify by maybe dividing both the top and the bottom by the same number. So in this case, I believe we can divide both -6 and -24. What if we divide them both by -6? Divide by -6. And remember, this is not necessarily part of the balancing of the equations, but what we're doing here is we're just simplifying our answer down because I have a feeling that your teacher might ask you to do that. So any number up top here divided by itself is always 1. Negative divided by negative is going to be a positive, and 24 divided by 6 is 4, which leaves me with my final answer down here of x equals 1/4. All right. And your teacher might ask you not to have the 1 in there. So if that's the case, go ahead and just leave your answer as x equals 1/4. I hope that this was helpful. Good luck with the activity. You can do it. I know it. Have a great day.